So I'm Michael Setton. I'll be talking a lot about Gaussian splatting today, so bear with me. Next slide, please. So we come from the world of IoT, and I was working for Vodafone before, and when talking about digital twins, we realized that it was really very fragmented, and it meant a lot of things. There wasn't really, if you ask somebody to define what they wanted out of a digital twin, you would ask 30 people and you would get 30 different responses. And this is some data from IoT analytics, which shows that it's very broad, and in a lot of people's minds, the digital twins were related to CAD/CAM and 3D simulation, because back in even 6-7 years ago, that's mostly what it was. As you can see, there are very different functions, whether it's collaborative functions or functions to improve operations. So next slide, please. So this is from Digital Twin for Defense publication, and what we preferred about this is that it shows that digital twins are not static in time. The functions evolve as people integrate new capabilities, and also we looked at what was defined as roadmaps back in 2022 for digital twins, and we couldn't see anybody, of course, who had imagined what the capabilities of AI are today. So that's why we think that since technology is accelerating, you have to almost adopt as many technologies as you possibly can to facilitate adoption and democratization of digital twins. And this is what we set out to do with our solution called Twinovators. So I will now explain how we progressively built the different blocks that constitute Twinovators today. Next slide, please. First, we defined what we wanted out of a digital twin by talking with various users, and of course, if you talk to companies like Dassault Systems, they want to integrate with CAD design software. If you talk to people who are in the construction industry, then they say, I want something that is integrated with my building information models. And if you talk to people who are in the medical field, they'll say, we want integration with, I don't know, patients' data or with a scan, MRI. So we thought about, what is missing, and what could now be possible thanks to AI that wasn't possible even a year and a half ago. And we selected an interactive digital twin where you have communication and interaction between the digital models and the physical world. So it's mostly, for example, related to the Internet of Things. If you have deployed sensors or even actuators, you want to not just see the data from these sensors. Say you want to be notified if there's a water leak somewhere, but you also want to be able to act upon it. So you want to be able to control a shut-off valve for the water supply, for example. So we set out to build this bidirectional capability in digital twins. Next slide, please. And the best way we found to do that is to actually use gaming engines. So they are not new, since you see the first PlayStation there 30 years ago. But what is really new is that the gamers, I've always been jealous of gamers because they always had the most powerful machines. And of course, NVIDIA, what made NVIDIA is it's the gaming industry, because really you need to have graphic processing units, GPUs, as opposed to CPUs. So because a lot of computing power was available for gaming platforms, we said, why not use that power for things other than entertainment? And actually now you see more and more gaming being used for simulation and even training. So next slide, please. So of course, we're not the first to use gaming engines. There've been a lot of collaborative projects. This is just an example of a European project that created a variety of applications for a digital twin of the ocean. So I'm not going to go into the details, but you can see, you just Google Iliad, and it's quite interesting. And they use a gaming engine called Unreal Engine, made by Epic Games. So we thought, well, why not use the same gaming engine? Next slide, please. And more recently, you also have a large software company called SAS Institute that uses the same gaming engine to build a digital twin for a paper manufacturer in the US called Georgia Pacific. And I've just put what how they summarized why they wanted to use a gaming engine for their digital twin. They wanted to simulate a factory environment. As you see in the middle of the picture, it says this is not a factory, but actually what they wanted to do is they have a variety of autonomous guided vehicles in the factory, ferrying those huge rolls of paper or carrying large objects, and they wanted to optimize the number of those AGVs, because each of them is quite expensive, but also make it safe for the collaboration between people and those robotic entities. And of course, they have to use AI for this, not just simulation, but also coordination and control. And I like their the phrase that they say, a digital twin makes reality work better. I think this is actually what anybody who uses digital twins wants to do is make reality work better for them. Next slide. And this is from a paper in April 2025, where people are starting to use a mix of spatial intelligence using GIS, but also, as you see in the titles, they're starting to use a new technique called Gaussian splatting. And so, of course, you're familiar with Google Maps and Google Earth, but I'll talk today more about Gaussian splats. So bear with me if you already know what it's about, but I think we'll do a bit of explanation because it's a relatively new technology. So next slide, please. Gaussian splats, they are about 2 years old. They were invented in France at INRIA, and they are really the JPEG, but for 3 dimension. And so it's basically split in 2 parts. There's the Gaussian, which refers to how the light and colors are distributed. It's a little bit like if you imagine a painting, the Impressionists, you have tiny pixels, but instead of having each pixel being defined, you would have a sort of rugby ball shaped Gaussian, and that would represent the position of the pixel, and also depending on where you are viewing this pixel from, you see more or less color or more or less intensity. So that's the Gaussian part. And then the splatting means that you are projecting this 3D rugby ball shaped onto the 2 dimension of your screen, where you are looking at the Gaussian splats. So you see in this animation on the left, you have what is a point cloud, which is what was used to display 3D before. And then on the right-hand side, you have a 3D scene that is rendered by Gaussian splat. And as you can see, it's very photorealistic. And also you can render it in real time in browsers, which is really what gamers want. If you are working with a character in a game, you don't want, as soon as you click on your mouse or you speak to an avatar, you want that to happen in the digital world. So next slide, please. So this shows how the Gaussian functions and how there are 4 factors that are it's called quaternions that are associated with a splat. So where it is located, how its shape, basically how it's stretched. So if it's closer to a sphere or really more like an elongated rugby ball game, which color it is, so RGB, and then its opacity or basically contrast and luminosity. So that's the Gaussian, and as you see, you project the Gaussian in a 2D plane, X and Y. So it's a very compact way of instead of having to define every single white point that you have inside this orange ellipsoid, you have those two functions. So it's a very compact way of defining a 3D image. Next slide, please. And how you capture that. So you can capture either images or video with off-the-shelf devices. So we capture with our splats with an iPad or with a Insta360 camera. And if you can also take videos and then break them up into images. So to give you an idea for how many images it takes, we did Gaussian splats of a room at Digital Catapult in London, and to have high resolution Gaussian splat, it takes about 2,000 images. But it's really easy, these days to have automatic mode and capture that. And as you see with the cameras, you have to take the images by pointing the camera at different heights. So typically you do 3 passes, top, as if you're looking at the ceiling, middle, and then looking at your feet. So of course, you get several hundreds of megabytes. So the processing is mostly done in the cloud because it's very GPU heavy. So either you're lucky enough to have a gaming platform, in which case you can do it on your local hardware, but typically it's done in the cloud. You upload your file, and it takes a few hours of processing to convert it to a Gaussian splat. But you only have to do this once, and then once the file is created, you can just navigate in it instantly. And what's also good is for large spaces, so mostly outdoor spaces, or say large buildings, you can stitch the Gaussian splats together. Next slide, please. Yeah, so this is just explaining the sequence. So I will speed up a bit. So you capture the photos, you export them, and here on the right-hand side, you can see different platforms that enable you to do that. Then it's converted to different formats with different degrees of compression. And then you have a content delivery platform that streams those Gaussian splats. And then it's loaded into your browser and rendered on your device using a web browser. And I've put a link where you can click. Can you click on the drone capture polycam? It should work. I hope.
We've only got a few minutes left, Michael.
Okay,
so,
okay. So next slide, please. Okay, and it's also gaining momentum quickly because in September, Meta announced something called Horizon Hyperscape. And actually, if you can click underneath, you'll see a short video. So just it's a few seconds, so just 10 seconds. If you can click there, it should be if you can play that. So this is what a Gaussian splat looks like. You can really, as you move about, you can explore, and it's almost like being there. And so this is in the consumer space, but we adapted it for the business space. And the standardization is moving quite quickly because now it's part of a 3D standard called GLTF. Next slide, please. And this is ours. So if you just click on the image, it should show the animation, and if you can click on, yeah, thank you. So you can just drag and drop where you've placed the sensors in the space. So this was captured very quickly, and then it was transformed. So nothing extraordinary. And then once you click on the device, you see IoT data. So of course you can see real-time data, but you can also look back at historical data. So very easy to use, really for non-technical people, and interactive. Next slide, please. So this is our overall architecture, and for Industry 4.0, for example, our customers have asked to have three most important features for them, whether it's related to carbon footprint reduction or energy reduction, improving their supply chain or their operational efficiency. And next slide, please. I won't go into that. And so this is just to show what we are working on for scaling. It's first of all to integrate different protocols. Doesn't matter whether you use Wi-Fi, LTE, or LoRa for the communication, it should all work the same. Security, of course, is becoming more and more important, especially after what happened at JLR. And also in terms of the user experience, we have to not just work on VR, but also make it possible for people to just use their normal device. A simple mobile phone should be enough. Next slide, please. Yeah, so we're using AI agents to facilitate, as I showed, device integration, have a good user experience, and provide a short time to value for digital twins. And we're looking for partners who, like us, want to speed up 3D digital twin adoption. So thank you for your attention.
What are the use cases of the 3D rendering beyond being an immersive model?
It's for anything that is where you need special intelligence, whether it's construction or defense. So I would say mostly when you're outside, so it doesn't matter whether it's smart cities or navigation, maritime, and whenever you are outdoors, I think there's a lot of value, because we're already familiar with 3D, for example, for Google Earth. So